Welcome, everyone. This is the Redis Cache and Intelligent Apps for dotnet session. My name is Catherine. I'm a product manager in the team.
Yeah, and I'm Stanley. I'm a software engineer on the Azure Cache for Redis team.
Okay, so today we'll look at how to use Azure Redis Enterprise with vector similarity search and a few associated application scenarios for it. We prepared a couple of demos on the RAG AI semantic caching and a few more, depends on how much time we have. And we'll mention security is important and it's very secure to run your application in Azure. So let's get started. Azure Cache for Redis Enterprise is a first-party offering in Azure. We have a partnership with the Redis Inc. So even though the Redis Enterprise software is not owned by Microsoft, the service in Azure has the entire first-party support, scalability, resiliency is unparalleled up to 5.9 SLA. Why Redis Enterprise? Because it has a search module that enables the popular vector similarity search scenarios in intelligent apps. Redis itself can be a decent vector database because it has built-in search capabilities, and we have great developer experience support. Like in the agent SDKs, we have a connector through semantic kernel, and we have popular open source dotnet libraries like stack-exchange.redis and Redis OM and Redis stack. Those are for using the modules and the search capabilities built on top of the Stack Exchange. So rich client libraries and tooling support, good search capabilities, and Redis itself has data structures like JSON and hash to store the vector embeddings, so we can use it with our application. So we talk about vector similarity search a lot, but what can it do for your intelligent apps? In the retrieval augmented generative AI scenario, a vector database can be used as an external knowledge store. So suppose if you have any documents that's internal to your enterprise, you won't want to train the GPT model to know everything about it, both for security, privacy, and also it's costly, expensive to train a new model. In that case, you want to put your additional knowledge in an external vector database, such as Redis. And you can then retrieve the information from it, augment your prompt, and then send to GPT for generating the chat completion. So that's one popular scenario for vector similarity search using a vector DB like Redis. Other scenarios include summarization, grouping, trend prediction that just by comparing the similarities or differences among the vector embeddings, it can deliver by itself. And you can incorporate it in your application. For example, you can recommend a similar item a user has purchased in an e-commerce shopping web app. And there are current scenarios for caching, like the user session, state data, distributed caching, output caching, and so on, which can all be incorporated into your intelligent application, making Redis a multi-purpose data store for intelligent apps. So let's get into the demo.
Yeah, thanks, Catherine. So another popular scenario for using Redis is as an external knowledge store for embeddings and other documents. So let's show a quick demo with an intelligent app using Redis. So you can find the code for this application here. So it's very simple to get started. All you have to do is go to the repository, press dot or period on your keyboard, and that'll open a code space. And once you do that, you can open a terminal and provision your environment. And so this is a service provided by or paid for by Azure Samples, so you don't have to worry about costs for this. So to set up your application, all you have to do is run azd auth and then set the environment to use Redis and enter an environment name. And then you enter the embedding type. This is specific to Redis. And then you just run azd up. And then this will provision resources in the subscription and region that you choose.
So the azd command, is it the Azure developer CLI? And is there any bicep backing this whole process?
Yeah, so the Azure developer CLI is a very simple, easy to use tool. It makes things repeatable, and this is fairly simple to use, I would say. So
I see all the PDF files being uploaded. It's pretty fast.
Yeah, there's a lot of PDF files in our application. So this is we take the documents, we send them to Azure OpenAI instance, which sends it to a function, which then sends the bit embedding to Redis with relevant metadata. So you can see it's processing all of the PDF documents, and then we'll be able to use them in our application.
So Redis is pretty scalable in this case.
Yeah, I would say so. Yeah, we can use it. Azure Open offers a variety of sizes for Redis, so it's definitely built for scale. So this is our chat application. We just click on the link after we provision it, and we can enter a question where we'll generate a response with supporting content. So you can see we have our answer to the question along with the documents that are relevant. You can see all of the documents that we uploaded and processed here, and those all have embeddings associated with them in Redis. So here's an example of using Redis as a semantic cache. So we entered the question, what happens to performance review? And we got our answer. And if we enter a very similar question, what is a performance review? You can see it returns the same response. Now this is a tool to view our Redis data called Redis Insight. This is a free and widely available tool from Redis. So we just enter our host name and password, and we can view our data. So you can see we have our semantic cache data with our prompt, question, and embedding information. And then we also have our document embeddings with the embedding and the associated metadata and content. So we could also run the profiler tool and see the commands executed in real time. So if we execute a query in our application, we can see that query reflected in Redis Insight as well.
That's one advantage for using Redis as the vector database through the tooling support.
Yeah, absolutely. That's right. So we can view that, verify that the semantic cache is working, and it did cache our question. So that's great. So that was the demo. You can find the code here. The demo Azure Search OpenAI demo C# on the Redis branch. So now I'll just briefly go through some of the code and show how simple it is to add this to your application. So I added two main functions to the application. One is the embedding service, and then the other is the search service. So to create the embeddings, first you have to create an index. So this is the method to create the index. It just executes the ft create command and then the parameters. You can specify a schema to use the metadata associated with your vectors. You specify the vector type, the vector dimension, and then the distance metric that you want to use.
That's all the built-in Redis search capabilities, and the index is all stored in Redis itself.
Yeah, absolutely. Yeah, it's and then this is creating the command directly and directly executing on a Redis, but there are also libraries such as Redis Stack, which offer additional functionality for C# as well. So you can see once we have our document, we compute our embedding with Azure OpenAI, we can just provide this information to Redis, and it'll store that in the database, and we'll be able to query it. So moving on to the search service. So we were able to query the documents. This is the primary query that we're executing. So you can specify the index, and then how many documents you want to retrieve, and then you supply the query vector, and it'll, based on the search function you use, it'll find the most similar documents to the query vector, and it'll return those results. And this is all done using the ft search command. And then finally, there is, we added functionality to use Redis as a semantic cache. So you can see we imported these two libraries, Redis.om and Redis OM.vectorizers. And this allows you to create a semantic cache using your API key, resource name, deployment ID, and dimensions. And then further on, you can check if a similar question has been asked before in the semantic cache. If it has, you can return the response. And if it's not, you just create the answer and cache the response. And so that's.
So that means when semantic cache is used, your application don't have to call into the GPT model again to generate the answer, right? Because everything is just cached.
Yeah, that's right, Catherine. So it can definitely reduce the burden on your application and those resources. And it's definitely something that you can tune as well. There's a variety of parameters that you can tune to set the sensitivity of the semantic cache as well.
Awesome. So basically, this is using Redis as the external memory store for RAG AI, and using it as a semantic cache for reducing cost and improving performance.
Yeah, absolutely. And keep in mind that Redis can also be used for a variety of other more traditional web functions, such as session state caching, output caching, and storing the chat history as well. And this is all stored in memory, as Redis is an in-memory database, so it's all very, very fast. So we can switch back to the presentation, and I can go over the architecture, which we briefly showed. So that you can see the presentation. This is the architecture. So we send the documents to a function, and we store those in Redis, and then we query those also using Redis. And it's it's definitely an exciting use of Redis in general.
It's very cool seeing just using one instance of Redis Enterprise, we could enable so many scenarios and features for intelligent app.
Yeah, absolutely.
Okay, so Stanley, you earlier mentioned there is an alternative for doing all the search command using Redis stack. So this is the Redis stack library that Stanley was talking about. I mean, as a developer, you have a choice if you want to write the Lua script and the commands yourself. Stanley showed you the way to do it. This is an alternative way. It kind of wraps the command a little bit and orchestrate all the function calls. So this library is maintained by Redis Inc., but available to everyone. It basically enables all the Redis module commands like search, JSON, time series, and so on. So you can check it out. I have another like demo application just showing if you use Redis stack, this is going to be how creating an index would look like and how search would look like. So not wrapping the raw command, but we have some functions here to make things a little bit neater. Yeah, and I think Stanley also mentioned about the semantic kernel. This is a Microsoft-owned but open source agent SDK. It has built-in memory support using Redis as the backend store. And we also have a blog post talking about how semantic kernel and Redis can work together to enable chat applications. So we talked about semantic caching a lot, and we know this concept is relatively new to people. What does it mean? If you have an application used by multiple users, like in a chat application, for example, there might be questions that are similar in meaning but asked in different ways. For example, where is the capital of France and where is the French capital city? In this case, there's really no need to go to GPT again and call the large language model generate a new answer because it's expensive, it could be time consuming. What we want to do is to store responses to this type of questions. And how we find or retrieve the value is through making the key of the cache entry to be vector embeddings, and we search through to find the entry with a similar key in meaning as we translate everything into vector embeddings. In OpenAI, Ada text embedding can do that for you. It's relatively lower cost comparing with like calling the GPT model for generating a chat completion. So for example, in this case, if a question got asked, where is the French capital city? We go through the embedding transformation, making this question query to be vector embeddings, and we compare through the list, like how to see which one is the most similar, and we retrieve something we found and then give the answer back. So in this case, it reduces the cost and improves your performance. And I want to show another application to emphasize on semantic caching a little bit more. This is an OpenAI art gallery. It calls into the DALL-E model to generate pictures on demand. So if I hit the semantic cache endpoint, and let's just do something new, a purple robot walking in the sky, because we are dotnet, we like the purple robot. Okay, I think it's blue. I may have to set the similarity threshold for like too low. Let me just clean the response and do it again. This is a nice tool, Redis Insight. Like I can just go into it to manage my data. I see there are some like previous entries. Let me just delete all these entries. Yeah, it's pretty simple to use this tool. So let's go back to the application again and try semantic cache a purple robot walking in the sky. Try again. dotnet plus Azure. Hope it works this time. So we see it's taking the time calling into the DALL-E model for generating the picture. Ooh, I like this one. So it's a lot closer to what I was asking for. Now, if another user comes in and maybe enter a prompt with similar meanings but different ways, like a robot that is purple in the sky. I'll say like walking in the sky. You see the response got reused. Picture returned instantly. There's no like waiting progress for calling into DALL-E again. So this is like another application for using semantic caching, and it's beyond the question and answer. Can be anything generated. Now, when I was displaying all the pictures, like my server had to render the HTML. And if a user keeps on refreshing this page, there could be like overly utilized CPU resources. So we wanted to reuse some of the previously rendered HTMLs. That's why we introduced the Redis output caching in dotnet 8. What this means is, for example, if I go to the cached endpoint, I see a French garden. The first time is calling into the backend DALL-E model again to generate this picture, but notice if I refresh it, because it's the same command, the HTML response will be cached, and it's going to reuse what was generated earlier. In this case, it will save the CPU resource utilization and also improving the performance. If we go to the Redis insights tool, do a refresh, we see the previous entries here. And this one is from the output cache, basically HTML or generated already to be reused. And for both scenarios, the coding effort is pretty minimal. To enable output cache in dotnet 8, you just have to firstly add the services. This one, add output cache, make sure output cache is enabled, and then stack change.redis, making sure Redis is used as the backend store. And you just say like dot cache output in your program application. If you want to add any additional configuration, you can do it either through the attribute or go back to the service initialization code to do it. So this is like a little bit about the new Redis output cache we shipped in dotnet 8. And regarding to the semantic cache part, it's very similar to what Stanley showed earlier. We use the Redis OM, and is cache.get similar and cache.store async for saving the command prompt with what's generated by DALL-E. And if you want to learn more about the vector similarity search, vector embeddings with Azure Cache for Redis Enterprise, this is our documentation, and the links plus the blog post, demos, everything will be in the slide deck. And we want to mention it's very secure to develop your application using our Azure Cache for Redis. We support application level, transport layer, and infrastructure level security. So when you code your application, you can make the entire experience quite free, leveraging the Entra ID. And there are well-established bicep files for configuring the VNet. I mean, bicep, ARM, Terraform, the choice you like. and we support the latest TLS 1.3. Okay, and yeah, that's all we have.
So, Catherine, there's some questions in the comments. One of the questions asks, can we tweak how similar the results are in the semantic cache? And so that's definitely something you can update and tweak as necessary. You can, yeah, there's different parameters you can use to modify that.
Yeah, sorry, I cheated through my demo, but like Stanley said, there are parameters you can use to define the similarity level.
Yeah. Another question we have, do the documents have to be written in a certain format, or can we send any documentation to be queried? The documents don't have to be in a certain format. You can use pretty much any document with text. You can use PDFs. You can, I'm sure you could change it to use something like a Word document or something like that. But anything that you can extract text from would work. You can also use it with images as well, and that's definitely a use case for that. Another question asks, can we use the caching for controllers? And that's definitely a supported use case. We definitely support the model view controller framework. Yeah, you can use output caching and semantic caching with that as well. Yeah, so I think that addresses most of the questions.
Awesome.
Well, thank you so much. And yeah, just another reminder, every, let's see, that's the 4th Tuesday of the month. And I think your next community stand-up is actually on May 8th. Isn't that right? I think we had to reschedule one of them. So if you'd like to hear more about how to use Azure Cache Redis and from our wonderful presenters and speakers today, they will be joining every month on this YouTube channel. So just subscribe to the channel and you'll get lots of great content, lots of opportunities to ask more questions and to learn about more features that we offer. Thank you all so much for joining today.
Thank you.
Thanks, everyone.